So, take a look at this video. The student seems to have his robot drive around the field, knocking down the obstacles using computer vision.
Ready, Eric. Yes.
Set, go. First person view.
First person view, hitting those tags. Boom. One tag is gone. Hitting the other one. Finding.
At the 360 for no reason.
Nice. Yes, that's right. I think you can fix that code.
Nah, that's fine. It gives it style points.
Boom. Style points. Alright, well done. All 3 tags have been hit.
Okay, good news is, so long as you have your XRP robot in your hands, you can do it too. Let's start. Fortunately, we have the source code that he started with. The link is in the description, so let's fire up PyCharm. And we can hit this button, Get from VCS. If you have a newer PyCharm, this button says Clone instead of Get from VCS. Putting the link in here and hitting Clone. The code is downloaded, so we click the lower right corner and select the version of Python. Add new interpreter, add local interpreter. Python 3.9 is what we want for this. The version of Python is chosen. Now we have to click on this requirements file, requirements.txt. See, everything is highlighted in yellow, so we need to right-click the button to install all missing packages. So I could just click it and it would work. But what if you don't see this button? You can go to terminal in this case. So here in your PyCharm, you can hit this button, terminal. And after you have terminal open, you can say pip install -r requirements.txt. And all that's needed for this code to run will be downloaded and installed, as if you clicked this button, install missing packages. The requirements are installed, so here we can open file robotcontainer.py, all the way on the left. And inside of there is some code to drive this robot autonomously, if we want it to drive autonomously. If you scroll all the way to the bottom of this file, there is this function, getAutonomous command. There are 3 ways to drive the robot around the field to knock down the obstacles. One is called AutoZero. It consists of 2 commands, go to point A, then to go to point B, and they all get connected like this, with a magic function and then. So that's one way to knock down the obstacles. The other way to knock down the obstacles is to use trajectories. Trajectory is a way to say, hey robot, go to X and Y, but as you go there, you must pass certain waypoints, so it becomes a curvilinear trajectory. You can connect one trajectory to knock down one obstacle and another trajectory to knock down the other obstacles using this function and then. And then what we get is a command called auto1. So you can use trajectories to knock down the obstacles. Finally, you can use the camera in a command to find object, follow object, and charge at an object by driving 10 distance after finding the object and approaching it. You can do it with one object, with 2 objects, 2 obstacles, and connect everything together with and then. As a result, which auto we will choose? We can choose auto 0, or we can choose auto 1, or auto 2, or you can create your own auto inside of this function, your own autonomous driving logic, and the robot will do exactly what you said. Finally, if you have a robot like this, that does not have a camera, what you want to do to run this code is you want to pick a configuration here to run a robot without camera, like this, and then you can hit the run button. Or if you want to run this same code completely without a robot, you can hit this, without robot, and run it, in which case the camera will be the camera in front of the computer. Look, the code is running, and I think I'm going to get a video of me. There we go. Maybe. Here, I have this little XRP robot here sitting on my floor, and let's see if it works. I'm going to, because this robot does not have a camera, I'm going to use a trajectory that consists of point A and point B, but let's add another point to it. Point C equals go to point, and the coordinates will be 40 inches for X, 30 inches for Y, using the same drivetrain. And I'm going to connect those points, first point A, and then point C, and then point B. And this autonomous command is what is actually used by this robot in autonomous mode. So what I need to do in order to make it happen is I need to connect to the robot Wi-Fi, which I am already connected, and then I need to choose the configuration, robot without camera. If your robot has a camera, you should choose robot with camera. Robot without camera is going to be mine, and if you just want to run it without a robot, you can use the third. So choosing robot without camera. Very good. The robot is in here, and if my code is correct, I can start the robot code in here. I see the simulation graphical interface. When I switch it to autonomous command will run. It's driving to point A, then making a U-turn, driving to point B in here, and finally back to point C. Too bad I don't have obstacles placed on them, because it would have knocked them down. Now, what if your robot had the camera? If your robot had the camera, you could have chosen to use this option 2 command, which uses the camera to find objects, follow them, and knock them down. Then find again, follow, and knock them down. The only thing you need to change is this function must return auto 2 in here. And then, yes, everything will work. Just here you have to say robot with camera when you run it. This is the correct configuration. In the link under this video, you will see another video for how to actually put a camera on an XRP robot. So you can try exactly this. This is one of our student videos, and I think he explains pretty well. Now, many of you are going to ask, hey, you didn't tell us anything about how a robot actually looks at the video and detects objects on it. That's a huge topic, but there is a much longer video linked in the description. You're welcome to watch it. And it also tells you how to connect the camera to your robot in a way that it will work for you. Thanks again for watching, and if something doesn't work, just post in the comments.